Ever searched in a long winding document for an answer? You know it's in there. Somewhere in these 40 contracts, somewhere in this 88-page PDF regulation. So you do what everyone does. You hit Ctrl+F and you type the word of which you're sure that it is describing the problem, and then Ctrl+F returns that it's not there. It's lying to you. The answer is there. The document just didn't use your word. Today, I built the thing with you that finds answers by meaning, not by matching letters. And I built it on one document, so you can point the exact same workflow at your pile of 40, 50, or however many documents you have. And it works the same way. So here's the puzzle. How do you search for something if you don't even know which words are used? Ctrl+F matches letters. You need to match meaning. Those are not the same. And the gap between the two is exactly where your evening goes. Here is the whole thing. And it is a template you will reuse. One document goes in on the left. You ask it a question on the right, and I'm using here the GDPR regulation as an example because it's public. And I will show you every step. Swap your folder of contracts or documents in later, nothing changes. Now let's earn it. Old way first. My boss needs one thing. How fast do we have to report a data breach? I open the regulation and it's a pretty substantial document, 88 pages. And I search the obvious word, deadline, and what you can see here is it returns 0 matches, nothing. And the answer is definitely in this document. But the lawyer or the lawyers who created this were writing words like without undue delay and not later than 72 hours. They never once typed the word deadline. That's the trap. Ctrl+F has no idea what you mean. It only knows what you typed. Now multiply this by 20, 30, 40 regulations, 40, 50, 60 contracts. These are exactly the hours we're about to win back. Okay, let's have a quick look at the workflow. At the beginning here, we have a PDF parser node, and this PDF parser basically reads the document in. Today, that's the GDPR PDF. Tomorrow, it's your folder of contracts. The same node does exactly the same thing. Next, we do have this sentence extractor node, and the sentence extractor node chops the whole document into bite-size passages, one sentence each. So why chop it? Because when you ask a question, you want the system to hand you the one sentence or the few sentences that answer that question and not all 88 pages back in your face. And here is the idea the whole workflow rests on. A computer can't feel meaning, but it can turn meaning into numbers. Watch. Every sentence gets fed to an AI model here that reads it and boils it down to a long string of numbers. Think of it as a fingerprint of what the sentence is about. As you can see here, just like in the last video, we're using the same chain of connections. We're connecting to OpenRouter here using the OpenAI compatible model, so to say. If you want to understand better how that works, let me know in the comments below. But in general, OpenRouter is a big marketplace and we're using the models from there. So we feed that, a OpenRouter embedding model here, into this FAISS vector store creator. Back to what I initially said, what the sentence is all about. The interesting part is that two sentences that are very similar in meaning get nearly the same fingerprint by this vector store creator, even when they don't share a single word. report within 72 hours, and notify without undue delay land right next to each other. The sentence, "My cat is hungry," lands miles away. That's the whole trick. We stop measuring words and instead look at how close two meanings are. Let's have a quick look at what model we selected to do this. Here in the OpenAI embedding model selector, you can see that we have used the so-called text embedding 3 large model, because this one is not only dirt cheap, it does its tasks very well. This is the model that's exactly creating those fingerprints. One flag for later. Right now, we take that model from the cloud. Hold that thought for a few more moments. We'll get back to that. Next is the FAISS vector store creator. It takes every sentence and its fingerprint and files them in a store built for exactly one job. Given a new fingerprint, instantly find the closest ones. It's an index, but organized by meaning and not alphabetically. Build it once, search it forever. For this demo, it lives in the memory and rebuilds basically every run. For your case, you might want to save it to your disk, so you never have to re-fingerprint the same document or documents twice. Now for the table creator. This basically just holds my question, which you can see here. How long do I have to report a data breach? Next is another important node. It is called the vector store retriever, and that is basically fingerprinting the question the exact same way and then ask the vector store which sentences are closest in meaning to it, nearest. Never an exact match. So let's just hit run and see what results we see. And you see here that looks already very promising. We get a collection list. So the same question, Ctrl+F, choked on 60 seconds ago, right? And it pulls back the exact passage here. For example, here we can see in the case of a personal data breach, the controller shell without undue delay, and so on and so forth. We'll also find that 72 hours after having becoming aware of it in here. And my question said, how long and report? The answer says 72 hours and become aware. I barely share a word, and it found it anyway because it searched what it meant. The last few nodes that you see here, the ungroup, then the group by, a bit of formatting, just tidy the whole thing up a little bit so that it leads into a clean, readable table. That's cosmetics, don't overthink them. And notice what it did not do. AI did not write an answer. It didn't summarize, it didn't invent. It pointed at a real sentence in the real document and said, there, read that. That restraint is on purpose. And it is the theme for the next video. Step back. What did we build? Not a GDPR app. We built a template, pointed at a document, and it makes that document searchable by meaning. The document in this case was GDPR because it is public, you can revisit it, and I can show you every note. Swap that one PDF parser input for a folder of 40 notes, 40 policies, your whole shared drive, and not a single other note changes. That's the part you keep. So here's the final result. The question, the answer. Two honest loose ends. And they make the next two videos. One, you notice that I still had to read the passage I found. It located the answer, it didn't write it. Next video, we put an AI on top that reads that whole passage for you and responds in one sentence with the source. That's when this really becomes chatting with your document. Two, The sharp-eyed among you probably caught it. To make those fingerprints, I sent the text to a cloud AI. Totally fine for the GDPR policy because that's public. Not fine for your real contracts and your real documents. So in video 3, we rip the cloud out and run the whole thing locally on your own machine. Nothing leaves the building. Find it, then answer it, then lock it down. If you don't want to miss that, subscribe and we'll build the next pieces together. As always, the workflow to start from is linked in the description down below. You can download it for free. Point it at one of your own documents tonight and watch it work.